Okay, question 10 of the M7 practice paper. It says John and Jake think a dice is biased. What that means is that the probability of getting each score on the dice will not be the same. Okay, if a dice is fair, that means the probability of each event happening will be exactly the same. It would obviously be 1/6, but these guys believe that this dice is biased. They both roll the dice a different number of times, and the table below shows the results of their trials. So John, he rolled the dice 60 times and he got 12 sixes. Jake, he rolled the dice 150 times and he got 45 sixes. It says calculate the relative frequencies for each boy and complete the table. Now, relative frequency is an estimate for the probability of an event, and there is a formula for it. So the relative frequency is given by P, and it's equal to E over N. E is the number of times the event happens, N is the number of trials. So you can see here the event in this question is getting a 6, because it talks about number of sixes, getting a 6. So E is the number of times the event happens. So this column are your values for E. So the number of times the event happens. And then this first column here is N, the number of times the experiment is repeated, or the number of trials which take place. So that's our values for N. Now, to get the relative frequency for John and Jake, we're going to start with John, and we're going to divide 12 by 60. We're going to replace E with 12, replace N with 60, and get a value for relative frequency, and we're going to do exactly the same for Jake. So let's start with John. So the relative frequency that he gets is equal to E over N, and that's equal to 12 over 60. And again, it's easier to do this on the calculator because you're going to be comparing the two relative frequencies, and it's hard to compare them when they're fractions, and particularly when they don't have the same denominator. So divide 12 by 60, and that's going to give us 0.2. So that's the estimate that John gets for the probability of getting a score of 6 on the dice. And then let's take Jake. And again, his estimate for the probability of getting a 6 is equal to E over N. So remember, E is the number of times the event happens. So in his case, there are 45 sixes that he records, divided by N, the total number of trials, which for him is 150. And again, we're going to divide 45 by 150, and that is going to give us 0.3. So you can clearly see here that there is a suggestion that the dice is biased, because if the dice was fair, the probability of getting a 6 would be 1/6, because there's only one way you can get a 6. There's 6 possible outcomes. Now 1/6, if you worked it out, would be about 0.166666. So again, these are estimates. Now, it says in part B, which boy's relative frequency gives a more reliable estimate of the likelihood of rolling a 6 and why? The more reliable estimate for the relative frequency is the one where the most trials has been carried out. So you can clearly see Jake has performed more trials than John, so his relative frequency should be more accurate. So the answer is Jake, and the reason he has performed the experiments or the trials more times than John.